back to class. I'm super excited to have you back to class again, guys. It's going to be mind-blowing once again. Now, please don't forget, if you are new in this YouTube channel, do consider subscribing to this YouTube channel and ensure that you turn on the post notification bell for more exciting videos. And don't forget to like this video when you're done watching this video. Share this video if you find this content helpful. Now, also, don't forget that this is Master Builders Academy, where you must not skip any part of this video. You must ensure that you avoid every unnecessary distraction, and you also ensure that you replay the video over and over again until you get the full understanding of what this video contains. Now, guys, let's get to work. On the board, we have measurement. Of course, you have been looking at measurement for quite a number of time now. And in today's class, or in this particular class, we are going to be examining the concept of measurement of mass, length, and time. Of course, by now you should know what mass, length, and time are all about. They are the three major fundamental quantities that are much recognized in physics. We have others, but these three are the most important. The most important among all other fundamental quantities. And now, guys, being the fact that they are most important, like I explained in our previous class, I made it clear that 90% of the things that we are looking at in physics, you have ever looked at and you are ever going to look at, depends solely on these three fundamental quantities. That means we need to give more time to know what they are actually all about. That what we have discussed so far is not enough to be able to work with these parameters or these quantities. And that's the reason for this current video. So that we can unveil more about mass, about length, and about time. Now let's quickly start with mass, guys. If you are asked, what is a mass? Or what is mass? What will you say? Now, guys, mass is the measure of the quantity of matter present in the body or an object. Now, listen carefully. In physics, there are two things that we use for pursuit. Everything that we have, physical object that we have in physics, we either recognize them to be body or object. Take note of that. So I can use body, I can use object. Alright? So in physics, physical objects that we can touch, we can handle, they are mainly referred to as either objects or a body. So get me when I mention body or when I mention object. Any of the case, we are right. Okay? So mass is the measure of the quantities of matter present or contained in an object or in a body. Contained. The quantity of matter contained in a body is called mass. Now, this is a water, alright? A sachet water. And this sachet water contains a water. What we have inside this sachet, this nylon, you call it, is mass with respect to volume. And maybe this is 60 cl, right? Yes, 60 cl. When we are talking about the volume, quantity. And now we said that matter is anything that has mass and occupies it. Now this water here occupies a space. Now in my hand, as it is, it occupies a space. As I suspend it above the ground level, it occupies a space. So it is a matter and it has a definite volume. Alright, so mass is the quantity of matter present in the body. Now, this is a marker, it has a fluid inside. This is a marker. The component that makes this marker is called a mass. And they all have their respective volume in which they will come. So this is matter. This board that we have here now is a matter. And what makes up this board is what we call mass. So is the quantity of matter that is available or that is contained in a body or an object. So If this nylon, which is 60 cl, contain a water, and the water is indirectly what 60 cl. Is that correct? Yes. So this is it. So mass is the quantity of matter that is available in an object or a body. Now, having get to know this, we already know that mass is a fundamental quantity, and it has a fundamental unit called the kilogram. Of course, there are other units of mass, which we have kilogram, we have gram, we have milligram, centigram, etc. Alright? These are basic units of mass. But like I said earlier, in physics, all of these units that are here are not used but can be given. So you can be given a mass in this, but there is a call for conversion. You must convert to kilogram before you can use it, because internationally it is kilogram that is accepted, not gram, but you can be given in gram. Then you must convert to kilogram. Similarly, if you are given a milligram, you will convert to kilogram. And likewise, if you are given a centigram and any other gram unit, whether mega unit or mini units, you need to convert to kilogram before you can put that value to work. Now, what are the instruments used to measure mass? Of course, this is an online video, so I'm going to make it short. I'm going to mention only their names. Then you can go to make your findings on how they are used. All right? Now, what are the basic instruments that are used to measure the mass of a body or an object? Can you give me one? Give me one. Now, the number one is beam or chemical balance. Number two is also what we call the lever or lever balance. Then finally, number three is top pan balance. So these are the major equipment, tools that are used to measure the mass of a body. So if I need to measure the mass of this now, all I need to do is to place this on beam balance, lever balance, or top pan balance, and I will be able to get, it will give me the readings. Although these things we just mentioned now, some of them are electronics in nature. Alright? So when you place this in any of these, depending on the one you are using, it will give you the readings of this. The reading, the capacity of what we have here. Are we there? So this is it. Then there is also another way to be able to get mass from calculation. And this is what we call weight. Alright? So under mass we have weight. So if I know the mass of an object, indirectly I also know the weight of the object. Alright? If I know the mass of an object, indirectly I know the weight of an object, because the weight of an object is the mass of the object multiplied by acceleration due to gravity. For which I can also make the mass the square of formula, and I will have weight divided by what? Acceleration due to gravity. Now understand that in physics, at this your level, acceleration due to gravity is 10 meters per second square. For university students, is equal to 9.81 meter per second square. Alright? But for secondary school students, this is what you make use of, except you are given this. Alright? Now, anytime I know the weight of an object, I can get the mass of the object by simply dividing the weight of that object by the mass by acceleration due to gravity. Similarly, if I know the mass of an object and I want to get the weight of the object, all I simply need to do is to multiply the mass of that object by acceleration due to gravity. So therefore, what is weight, guys? What is the weight of an object? Or the weight of an object is the measure of the gravitational force exerted on the object by the earth. The measure of the gravitational force exerted on the object by the earth. Now, if for instance I want to get the weight of this object, now as I suspend it this way, the force of gravity is pulling it down. Are we there? Yes, it is being influenced. So if I decide to let this be, it cannot be suspended yet. Why? Because the gravitational force we have to push this thing down. Are we there? Now, that force that pushes it down is what ascertains the weight of this object. So for me to be able to get the weight of this object, I simply multiply this mass by the gravitational pull on it. So that is the reason why the weight of an object is this quantity here multiplied by the force that is pushing it down. Are we there? Yes. So the weight of an object is actually the measure of the gravitational force that is exerted on what an object by the earth. Now listen carefully. The weight of an object is measured by an instrument called the spring balance, should in case you are asked. So spring balance, spring balance is an instrument that we use to measure the weight of an object. So at this point we will stop here for mass. Now let's quickly look at length. Now guys, what is length? Now length is also a fundamental physical quantity that has a fundamental unit called the meter. Are we there? And it has other units like centimeter, millimeter, kilometer, decimeter, etc. Just like that. These are the units of measurement of length. But generally in physics, it is meter that is accepted. So when you are doing a centimeter, given in millimeter, kilometer, or decimeter, or any other unit of length, you must convert to meter. Now guys, what is meter? The meter is the measure of separation between two distinct points. Now, if this is what I have here, maybe this is a table. For instance, I have the table legs, okay? Then I have this is a table, for instance, all right? Now, from here to this point is what we call it. Now, this is a point that can be labeled as A. This is another point that can be labeled as B. So this distance, the space between point A and point B of this object is what we call length. So length is the measure of separation between two distinct points. And now we said that length are measured in meter. Every other unit of measurement of length that you are given needs to be converted to meter anytime you want to use length for calculation. Are you there? Now, what are the instruments that are used to measure meter? We want to be fast because this video we took more time when we were explaining math. Alright? What are the instruments used to measure the length of an object or a body? Number one, okay, let's wipe this. Number one is the meter rule. Meter rule. This is one. Then two is tape rule. Tape rule. Alright? If I thought you don't know meter rule, you know tape rule, the ones Taylor use, right? Yes, the ones Taylor use, you know that. Now, if I thought you are not able to get it, please, you can go online. This is your Google and search for the images of all of these if you cannot find them in your textbook. Alright? Now we have the tape rule, which I said that most every one of us here have seen a tape rule. If you have ever seen a tailor, that rope they put on their neck to measure. Then we have what we call calipers. 3. Calipers. Now this caliper is divided into 2. We have engineers caliper. Then we have what we call Vernier caliper. Then 4. We have what we call the micrometer screw gauge. Alright? These are the instruments, equipment, apparatus that are used to measure the length of any physical object. Are we there? It's as simple as this. Just like that. It's as simple as this. So you see that you don't just jump into physics. There are basic things you need to learn. When you get these things known, you get yourself acquainted with this. As we move progress in this course, you will get full understanding of what physics is all about. Are you there? Now, this is all about it. Now, under after the measurement of length, we have the measurement of volume. Like I said now, we call this 60 cl some minutes ago. Alright? We call this 60 cl. This water here is measured in volume. I can put this somewhere and be able to read the volume of this, the quantity. I'm not talking about the material itself now. The material itself is the mass. I'm talking about the quantity. How much of this we have there. The amount of this liquid that is here. Are we there? So I'm talking about the amount of liquid. The amount of liquid that is here is what I'm interested in. That's the volume. How do we measure the volumes of what? Objects or bodies in physics? Like I explained earlier, I said that in physics, we have what we call matter because we are dealing with matters. And under matter, we have three states of matter. And I mentioned that majorly in physics, we look at solid and liquid. How do you measure solids, the volume of solid in physics? We have two types of solids. One is the regular solid, measurement of volume. Alright? One is what? Regular solid shape. For regular solid shape, the shape is known. For instance, if I have a cone, alright, I have a cone. It has a volume of 1/3 pi r square h. This is the volume. So all of these ones now, they can be derived, they can be obtained with a mathematical model. Are you there? Then we have what we call the what? The cube, alright? Here you have the cube. And now we have length. This one can be obtained length times length times length. Therefore, cubeboard, when you have something like this, then you have something like this, just like that. Then you have length times breadth times height. For cube, both sides are equal, so you have length all multiplied. So these are the ways. So when I know the shape, now if this vessel, for instance, now if this vessel is 10 milligram, whatever volume of quantity that enters here is exactly the same thing as this shape. If I have 20 liters gallon without any liquid inside, I call it 20 liters. Now, if I fill that gallon to the brim, the volume of water inside is what? Is 20 liters. Is that correct? If I have 5 liter gallon empty and I now decide to fill it with oil, how many volume of oil is there? Is 5 liters of oil. Why? Because the volume inside the vessel is directly proportional to the volume of the vessel. So if the vessel is 5 liters, the liquid inside it, as long as it is filled to the brim, is exactly the same volume. Is that correct? Yes, that's how it is. So if I am dealing with 20 liters gallon, whatever that is inside, once it is filled to the brim, that liquid inside is exactly the same amount as the volume of the keg. And that's exactly what we have. So this is the way to get that. Now, what about the second aspect of it, which we now call the irregular? Now we have this to be what? Irregular. The irregular shaped body or shaped object. Yes, the regular shaped solid. Now, in this case, where you have irregulars, now one of the things that happens to regulars is that, listen carefully, you can directly use any of these measuring tools to get these dimensions. I can use tape rule, for instance. Now we are common with tape rule, right? I can use tape rule to measure the radius of this cone. I just place it here and measure from here to here. I will be able to read the readings. I can also equally use it to measure the height, right? The same thing is applicable to this. I can use tape rule to measure this length, measure the height, and measure the what? The breadth. Similarly to this. So for regular shape, I can apply any of this measuring tool directly to get the measurement and then multiply out to get the volume. But for irregular shapes, none of these equipment here will be able to measure this. Why? Because the shape is not regular. Are you there? So if I have something of this nature and I ask you to measure this with any of these instruments, you will find it difficult to place a tape here. Are you there? Because when you have some of these things here that are not flexible. Unlike tape, now tape is a bit flexible. You can curve it, it can take the shape of whatever you have. Is that correct? But sciences, we don't accept it like that. Now, how do I measure the shape of this irregular shape? To measure the shape of irregular objects, there are two major things you do. Number one, it is either you get a what we call the Eureka can. Yes, the Eureka can, what you use to a can. Get the can filled to the brim. If, for instance, this is a can, I fill this, and this is the outlet here. Okay, now and this is opening, then this is the outlet, then I now have the cylinder here. Okay, this one is just like a bucket. All right, then I fill this vessel to this outlet, to this point of outlet, where it can possibly pour out if I add any other further liquid. I fill this vessel with a liquid to this point. Now, if I now gently, don't forget, gently insert this irregular shape into this vessel and allow it to move down till it gets to the bottom, the amount of water that will be displaced from this vessel to this other measuring vessel is equally the volume of this shape. Now, for instance, if I just drop this object, gradually drop this inside until the water begins to pour out, I allow the water to pour out till it stops itself. If I measure this volume here, the one that pours out, the one that was displaced when the object was inserted, the irregular shape was inserted, that volume that was displaced from the original vessel through which you inserted this object, that volume you measure that was displaced out is equivalent to the volume of water. Or otherwise, I can get a cylinder that has measurement and is wide enough. Then I put the water to this level. I fill it to this level. Okay? Then I insert the object. Then the volume will have risen from somewhere here to this point. So the volume that risen from, if the volume rise from here to this point, from this point to this point, the volume of water that I will measure within this space is equivalent to the object I insert. Because if I did not insert the object, the volume would have not rise. Now that I inserted the object, the volume now rises to a point. So the difference between where the liquid was before you inserted the object and the new position in that tail after the object has been inserted is what we call the volume of the solid. So when you take a measurement of that volume, it's exactly the same as the what? The weight of the object that was inserted. So this is how you measure the volume of solid irregular shapes of solid. Now, what about measurement of liquid? To measure liquid, you can use pipettes. For some of us who are very much good in chemistry, all right, you can use pipettes. You can use a burette. Either yes, you can use cylinder and so many other calibrated equipment that you can use. Are we there, guys? So to measure all of this, these are the things that you need. Now, finally, we want to quickly talk about time. Now, what is time? Of course, we know that time is also one of the fundamental physical quantity that is among the three most recognized physical quantities. Are you there? Yes, it's one of the most recognized physical or fundamental physical quantity. And the SI unit of measurement is seconds. And you can be given in minutes. You can be given in hours. You can be given in days. You can be given in weeks. You can be given in months. In fact, you can be given in years. You can be given in details, just like that, in decades. Are you there? This is it. These are all units of measurement of time. But guys, listen carefully. If you are given the unit of measurement in minutes, you must convert to seconds before you make use of it. If you are given in hours, you must convert to seconds before you can make use of it. If you are given in days, you must convert to seconds before you can make use of it. This is what is accepted. Because we accept K, what M, K, X, meter, kilogram, seconds. Are we there? Now, what is time? Time is the measurement of duration of an event. Are you there? Time is the measurement of duration of an event. The time, the duration it takes for an event to be accomplished. So if, for instance, I say, okay, let me take my journey from Abuja to Kogi State, for instance. The duration it will take me to move from Abuja to Kogi State is what we call time. So time is the measure of duration of an event. Or I decide to put food on fire. I want to cook beans. The duration between when I put the food on fire and when I remove it and I'm now satisfied that this food is ready for consumption is what is called duration. Or I now decide to start eating. The duration it took me to eat a particular meal till I'm satisfied is called time. And practically, there is nothing we do on earth that does not involve time. In as much as it involves our present, there is nothing. I take time teaching you now. Is that correct? The duration it took me now, if you look at this video now, is up to 20 minutes or more. That is time. So it is the duration to which something is gotten, an event is obtained. So that duration between when an event started and when it ended is called time. And of course, we use time more in physics as well. So now, what are the instruments used to measure time? There are so many instruments that are used to measure time in physics. But you will get to know a few of these now, which I will mention. Then you can add to them either via your textbook or you can go to Google and search for more. Now, one of the instruments, apparatus or equipment used to measure a time, all the time, is water clock. You can check the image of that. Then we also have what we call the electric clock. Electric clock. Then we have what we call the stop clock or the stopwatch. It's either we call it the stop clock or stopwatch. Are we there? Then we also have what we call the pendulum clock. Pendulum clock. Then we also have what we call ticker tape timer. Ticker tape timer. Then finally we have what we call chronometer. So these are the apparatus that are used to measure the duration of an event. And the duration of an event, like we said, is the measure of duration of an event is called time. So the duration between the starting point of an event to the ending point of that particular event is what we call time. So guys, in our next video, we will be looking at how to convert these units of measurement. How to convert from gram to kilogram, how to convert from kilogram to gram, how to convert from minute to second, hours to seconds, days to seconds, weeks to seconds, months to seconds, years to seconds. Then also how to convert from kilometer to meter, centimeter to meter, millimeter to meter, and so many other conversions. This will be the basis of our next class. Please guys, don't miss that class. And the link to that class, you will find it at the description below. Don't forget to like this video, share this video, and ensure you like this video before you move or progress to the next video. We love you guys. Ensure that you follow us in all our social media platforms, like all our videos, and ensure that you introduce this social media platform where academics is made easy for students to your friends, enemies, and well wishers. We love you guys. See you in the next class.